So as we move to question 5 and we're attempting to draw a chair conformation, remember that with questions like this, there's two goals that we're trying to achieve. One is to get as many substituents as possible into equatorial conformations. And the second goal is to get the largest group possible into an equatorial conformation. Now, if we have a very large group, then that issue predominates. We want to get that largest group equatorial. Now, do we have a group that applies to here? In fact, we do. We know that if we have a tert-butyl group, that tert-butyl group always needs to be equatorial. So that equatorial group is pointing up. So I've just picked an equatorial position that's up and stuck the tert-butyl in. Now, there's not another group substituted onto that carbon. So at the other position, I had either better draw the hydrogen in or erase that bond completely. If I leave it like this, then that implies that there's a methyl group, axial. And clearly there isn't one. So again, I either need to do it this way, by erasing the bond entirely, or by drawing a hydrogen in. Alright, so I'm going to go this way now. The next carbon has an iodine pointing down. That's our equatorial position. And a 7-carbon chain pointing up. We move to the next carbon. We have a bromine up and an ethyl down. The next carbon has hydrogens in both positions. Then we have an isopropyl down and a hydrogen up. And finally a fluorine up and an ethyl down.